Welcome once again, bizarre creatures enthusiasts. As we embark on a meticulous, comprehensive biological investigation into the sophisticated evolutionary regression prevalent within the planet's most isolated, specialized, and historically predator-sparse ecosystems, the islands of New Zealand, our subject today is the kiwi, a stunning, small, flightless ratite whose very existence in the dense, high-humidity temperate forests is predicated on extreme sensory specialization and near-complete abandonment of classical avian characteristics. The kiwi presents an unparalleled masterclass in convergent evolution, employing a combination of dense bone structure and specialized olfactory dependence, resulting in a physical presentation often described as honorary mammalian. The foundational element of their survival strategy is the alarming morphology of its nasal organ, possessing external nostrils nares uniquely positioned at the absolute distal tip of its long, highly sensitive bill. Chemically speaking, the nasal turbinates within the kiwi's bill are exceptionally developed, enabling a lethal, decisive chemical analysis of the subterranean environment, allowing the bird to swiftly detect the minute scent signatures of earthworms and larvae. At the critical level of sensory function, the kiwi exerts its effect by binding auditory input with tactile feedback, using its massive, independently movable ears to pinpoint the precise, minute acoustic anomalies indicative of hollow larval tunnels within the wood. At the critical level of sensory function, the kiwi exerts its effect by plunging its specialized bill directly into the soil, performing a rapid, intricate sniffing motion to create an olfactory map of the subterranean ecosystem. This binding event is catastrophic for the earthworm prey because it locks their position into an irreversible olfactory trap, completely overriding the soil's sophisticated defense mechanism that normally ensures silent, precise subsurface movement. The resulting continuous, uncontrolled chemical analysis instantly and permanently exposes the prey's location, causing persistent and forced extraction by the animal's powerful leg muscles and rapid consumption failure for the prey. The historical context of this morphology is critical. The kiwi's evolutionary path, shared with extinct giants like the moa, was shaped by New Zealand's lack of native terrestrial mammals, allowing the bird to fill a niche typically occupied by hedgehogs or badgers elsewhere. Their method involves a deliberate, non-lethal, yet highly efficient probing of the forest floor, allowing the precise collection of high-protein invertebrates, a perfect example of sustained ecological utility through morphological innovation. The most profound biological enigma surrounds the bird's egg. Despite being relatively small, the female kiwi produces an egg that is proportionally larger than any other bird in the world, often occupying up to 20% of her entire body cavity. This specific anatomical specialization within their reproductive system essentially renders their entire physiological system chemically resistant to chance, preventing the fatal energy expenditure that affects every other generalized omnivore. Crucially, the kiwi does not engage in extensive flocking or migration. It operates purely as an ecological anchor, systematically utilizing micro-reservoirs of high-nutrient invertebrates to fuel the massive metabolic demand of egg production. Focused ecological research has definitively linked the kiwi's population stability to the prevalence of specific forested areas, primarily native podocarp and beech forests, which are believed to be the necessary intermediate host for their specialized burrowing nests. This highly specific trophic cascade implies that the ultimate energy precursors likely originate in the unique plant life of New Zealand, are then ingested by the beetles and finally concentrated by the bird. A triple-layered ecological dependence. The kiwi has evolved specialized, densely packed, hair-like feathers distributed across the entire body, which function exclusively as secure, permanent insulation depots for heat and specialized protection against the nightly jungle elements. upon even minor mechanical stress or perceived threat. These animals instantaneously utilize their powerful legs and specialized bill for balance and detection, creating a rapidly effective, ready-made sensory mantle that deters any potential intrusion attempt. This remarkable defense mechanism is entirely conditional, as evidenced by the dramatic contrast observed in their parental roles. The male typically undertakes the sole, arduous task of incubating the massive egg for up to 80 days, lacking the necessary rapid flight or highly visible social displays common to other large wading birds. The kiwi is biochemically incapable of engaging in rapid, widespread dispersal or competitive feeding frenzies. This critical observation provides irrefutable evidence that the kiwi's powerful survival is an environmentally determined phenotype, inextricably linked to the unique, complex structural composition of the dense New Zealand forest habitat. The loss of its specialized forest habitat and the introduction of mammalian predators presents a dire, dual existential threat. Not only is the bird losing its physical home, but it is simultaneously losing the entire biochemical supply chain essential for its specialized feeding mechanism. The incredible diversity across the Apteryx genus shows a profound singularity. The kiwi is the only surviving member, a fact which reflects the precise, localized dietary specialization of this particular species. The incredible diversity across the Apteryx genus shows 5 distinct species, each reflecting the precise, localized dietary specialization and habitat pressures of their particular island and forest environment. Beyond the aggressive foraging, the kiwi exhibits surprising degrees of obligate parental care, with the male vigilantly guarding the massive egg against desiccation and pathogenic fungal infection for weeks after the chick hatches. The dedicated father undertakes the arduous, dangerous task of constant protection, navigating the forest matrix to locate isolated, predator-free micro-reservoirs of high-quality food. In certain individuals, the animal exhibits an extraordinary level of direct provisioning, utilizing its massive incisors to crack specialized, hard-shelled nuts directly for the juvenile as a necessary, high-nutrient food source. The newly hatched chick, which is already fully feathered and surprisingly independent, receives an extraordinary level of direct provisioning from the yolk sac that remains after hatching, providing high-nutrient food for its first week. This high investment in offspring survival, contrasting with the animal's solitary, intimidating presence, beautifully illustrates the profound and often paradoxical evolutionary pressures at play in complex, high-mortality environments. The specialized foraging technique itself remains a cornerstone in modern biomechanics, providing a perfectly calibrated, highly selective probe for studying the kinetics and structure of specialized sensory perception in human olfactory systems. By meticulously studying the sniffing patterns and olfactory analysis, scientists aim to design specific sensor systems or novel synthetic tools that could revolutionize the detection of subterranean resources and environmental toxins. The chemical arsenal of the kiwi's diet collectively represents a vastly unexplored behavioral reservoir, holding untapped potential for developing new classes of biomimetic systems focusing on ground-level navigation and resource detection. The evolutionary phenomenon is further confirmed by the discovery of similar probing and scraping techniques in unrelated species, like the bandicoot of Australia, reinforcing the concept of a shared dietary and ecological sourcing strategy. The kiwi's detailed life history and chemical ecology serve as an invaluable living textbook on the intricate, often violent, balance of energy exchange and resource partitioning within the island environment. Their unparalleled combination of extreme bizarreness, profound specialization, and specialized ecological dependence solidifies their status as one of the most enigmatic and scientifically crucial organisms on Earth. This intense scientific breakdown should leave no doubt that the most bizarre, visually shocking inhabitants of our planet frequently wield the most powerful, meticulously engineered, and deeply mysterious biological secrets. Now, we turn the focus back to you, our dedicated audience. Following this deep exploration, which other creature possessing extreme, bizarre, or unique skeletal or behavioral properties should bizarre creatures investigate next? Please share your suggestions for future topics, along with any specific questions you have regarding the kiwi's egg size or its olfactory foraging process in the comments section below. We value your critical engagement. If you found this granular, scientific dissection of the kiwi and its ecology informative and stimulating to your curiosity, please take a moment to hit that like button to significantly support our specialized content production. Thank you for joining us for this highly detailed session of bizarre creatures. Stay intensely curious, and we will continue the relentless pursuit of the world's most shocking biological truths together.